Have you ever come across a piece of code that left you scratching your head? If you've ever wondered why we use step forward in concepts, you're in the right place. Today, we're diving into this intriguing topic and unraveling the mystery behind it. I totally get it. It can be confusing when you see something that seems counterintuitive, especially in C++. You're not alone in feeling puzzled about the use of step forward in the swappable concept. Many developers have faced similar questions. Let's set the stage. One user recently asked, why use step forward in concepts? They shared an example from the standard library that uses step forward in a swappable concept. This raised questions about whether it supports reference types and why it seems to complicate things. So what's going on here? The use of step forward is crucial for perfect forwarding, especially when dealing with template parameters. It allows us to maintain the value category of the arguments, which is essential for ensuring that we can swap objects correctly. And stick around. By the end of this video, you'll not only understand why step forward is used, but also how it can enhance your coding practices. Trust me, you won't want to miss this. To understand why step forward is used in the swappable concept, the user should first recognize that step forward is essential for perfect forwarding. This allows the function to preserve the value category of its arguments. Next, the user should note that when T and U are reference types, step forward will maintain their L value or R value nature. This is crucial for the swap function to work correctly with both L values and R values. Now let's clarify the concern about calling swap with L values. When T and U are non-reference types, step forward will indeed yield R values. However, this is intentional, as swap is designed to accept R values for efficient swapping. Finally, the user should consider that the implementation of swappable is not wrong. The internal compiler error may stem from the specific compiler version or its handling of concepts rather than the concept's design itself. Fun fact, the concept of perfect forwarding was introduced in C++11, and it has since become a game changer for template programming. It's amazing how a small addition can have such a big impact. Now let's look at the answers provided by other users. This user explains that using step forward in concepts is about API design. They highlight that the swappable concept is defined to work with expressions rather than just variables. This allows for more flexibility in how swap operations are defined and used. They also mention that the swappable concept can be expressed in terms of another concept that directly supports reference variables. This distinction is important for ensuring that the concept behaves as expected with different types. Finally, the user notes that while concepts over expressions can be seen as a superset, usability from the perspective of concept clients is crucial. They advise caution when writing your own concepts, as there are many factors to consider. Now, let's shift our focus to a different response. This user points out that the use of step forward in the swappable concept might be a typo. They suggest it should use L value references instead, ensuring proper evaluation for both L value and R value references. This guarantees that only L value references are marked as swappable. They also explain that the full definition of the swappable concept includes both L value and R value references, which is why step forward is used. This allows for forwarding references to be properly evaluated. Lastly, the user addresses an internal compiler error with GCC. They suggest modifying the function signature to avoid this error, which is caused by how GCC handles concept resolution rules. Here's a pro tip. When working with templates, always consider how value categories affect your function calls. Understanding this can save you a lot of headaches down the line. And there you have it. Now you understand why step forward is used in concepts like swappable. Keep experimenting with your code and don't hesitate to ask questions. If you found this video helpful, hit that subscribe button for more insights.